In the name of God, the most gracious, the most merciful, welcome to a live lesson, Lady Khadija Online College, live lesson in A-Level Maths. Today is really the first lesson where you're going to see A-Level Maths truly at Year 2 level. So let me just add that in, Year 2. So far we've done revision of mainly GCSE stuff, and you also cover it in Year 1 of A-Level Maths, just to make sure you're solid on it. But in Year 2 we go far beyond that, and you're going to see that today. So let's get started. And if you're not ready for this because you've seen the first couple of lessons and you're thinking, oh, this is easy, this is just like GCSE Maths, and you're not really mentally sharp and prepared, and you're not really in tune, you're not really giving it your best effort, then you're going to be in for a bit of a shock, because suddenly things are gonna get quite hard quite quickly, and before you know it, you can find yourself drowning in A-Level Maths in Year 2. So if I was to give some advice, it would be, if you've not focused properly on any topic or any lesson so far in A-Level Maths yet, then today would be the first one where you really put in your best. And that really means reading through every example in the book, watching this video probably once or twice, and that way, even though the first time it might not make complete sense, you'll find that the second time it's a lot easier. And this is an amazing topic to get access to the really big exam questions that come towards the end of the exam and are worth lots and lots of marks. So if you can get your head around this topic, it'll open those questions up for you. If you relax a bit, just even a little bit, and you don't get this topic nailed, you don't get this topic 100%, then you'll end up losing a lot of marks and slip quite a few grades. So just be aware of that. Okay, Bismillahirrahmanirrahim, in the name of God, the most gracious, the most merciful. So over the last couple of lessons we've looked at adding and subtracting fractions. So I'm just going to give you a quick overview of that. So 3/5 plus 5/6. Let me just do that now. I'm going to change both into a common denominator. Denominator is going to be 30, but I'm not going to write it as 30. I'm going to write it as 5 times 6. That is 30, but you'll see, just for now, don't do this in your exam, but just so that you can see what's happening, I'm going to write the common denominator as 5 times 6. So this would be 5 times by 6 on both, which means I'll have 18 on the top, and then this one would be times by 5 on the top and the bottom, like the first one. I times on the top and the bottom by the same number, so this would be 5 times 5 is 25, add those two, and that would be 43, so I can replace that with 43. Okay, so that's just revision from last time, but the topic now, partial fractions, is about saying that, look, what if we only have the answer and we didn't have the two fractions that we added? Is there any way that we can just use the answer here to be able to figure out what those two fractions were? It's called splitting the fractions, and the key really is the denominator. So if you see that 5, the denominator is made up of 5 times 6, then that straight away tells you that the two fractions must have had a 5 and a 6 underneath. And then you can call the two numbers here anything you like, A and B. And what you're going to do is you're going to try and go through that adding process yourself. You're going to say, look, if I did have the fraction, add another fraction, if I did know what the numbers were at the top, what would I have done? Well, I would have times this one by 6, because I want a common denominator, and I would have times this one by 5. So even though you don't know the number on the top and the bottom, if you just call it a and b, then that'll be okay for now, because we can replace a times 6 as 6a, and we can replace b times 5 as 5b, and then we have 30 on the bottom from the 5 times 6, or I can just leave that as 5 times 6. So now I know that 6a plus the 5b has to make 43, because if all the bottom bits, 5 times 6, that's 5 times 6, that's 5 times 6, the order doesn't matter here, then if all the bottom bits match up, then I'm saying that all the top has to match as well. So the 6a plus the 5b has to make 43. So we can take the denominators away, just to give ourselves a chance to focus on the top. So it's 6 times something plus 5 times something has to make 43. And you'd have to use a bit of trial and error, but that's the principle. That's what we're looking at today. We're looking at not having the two original fractions, using any letter we like, a and b at the top, and trying to figure out what those original fractions were. So let's try one. This is the Pearson Edexcel Pure Maths Year 2 book, and we're looking at example 8 in the section of partial fractions. It's 1.3, so I'll just write that just so you know. Okay, and here's the question. Question is, we have a algebraic fraction. We have 6x on the top. On the bottom, x minus 3, x plus 1. And we need to find out what were the original fractions that made this one fraction. We want to end up with two separate fractions. So let's put those fractions in now. We don't know the fractions yet, but if you look at the bottom, if you look at the denominator here, you can see you've got two things timesing each other. So that's your biggest clue. That's saying that even though you don't know what the fractions were that added together to make this, one of them must have had x minus 3 on the bottom, and the other one must have had x plus 1 on the bottom, just like we did earlier with the 5 times 6. And then what do we put on the top? We don't know, so we're just going to put a. And we're going to put b on the second one. And now we ask ourselves that if these were just two normal fractions that I had to add, then how would I go about it? And that's where we did the lesson yesterday. So what we're going to do is try and aim for a common denominator. We're going to have to make this a little bit more spacious so I can get another bracket on the bottom. So what we're going to say is, if we look at the first fraction, we've got x minus 3. Take a sneak preview at the second fraction. It's got an x plus 1. So that's really what I'm going to be timesing by on the top and the bottom. X plus 1, x plus 1. Now the second fraction, we need to get that to have a common denominator. Well, I'm going to take a look at the first fraction that had x minus 3, and that's what I'm going to times by on the top and the bottom. And now, don't worry so much about the top, but look at the bottom and just check, are all the denominators the same? Is this the same as this? The same as this? And if they are, that's fantastic. That means we can cancel them all out, and we're just left with the top. So we've got a number a that we don't know what it is, times by x plus 1, add b, which is another number I made up, times by x minus 3, has to make 6x. So here the trick is that this has to work for any number of x. Whatever number x is, both sides have to give me the same answer. So you can actually, this is the first instance where you'll find in math that you don't have to try to find out what x is, and you don't have to stick to one number. What we're saying really is that x has to work across this whole equation for every single value. It's a bit like if you're saying that x plus 2x is the same as 3x. That has to work regardless of what x is. If x is 1, it'll work. If x is 10, it has to work. So if x is 1, that'll be 1 plus 2, and this will be 3 times 1, which is 3, so it works. If x was 10, x was 100, x was 50, it doesn't matter. X plus 2x will still always be the same as 3x. So similarly here, we're saying that whatever the a and the b are, if I times by x plus 1 and times by x minus 3, I'll have to get what 6x is. So you're allowed to put in any number you like for your x. So I can put in 0, 1, 5, it doesn't really matter. But I want to choose the number that's going to make my life easiest. Here, you see that I've got x minus 3. Well, if I use 3, then that's going to make my life really easy, because I know that that bracket is just going to become 0. 3 take away 3 is just going to become 0. So 0 times anything is 0. So that is just going to become 0. If I put x is 3 here, that's 3 add 1. That makes 4. So I'm going to end up with 4a. And if I said x is 3, I have to stick to it. So even on the left, even though I don't have a's and b's, if I said x is 3, 6 times 3 is 18. So that's what I have to write. And this is saying that my number for a, if I times it by 4, I'm going to get 18, which means that all I have to do now, if I get rid of that plus 0, I can divide both sides by 4. The 4 cancels here, and I'm left with a is equal to 18 over 4, which I can simplify as 9 over 2. So that's my first really good answer, because that's going to help me work out my first fraction. But now I need to work out b as well, so I'm just going to write in the corner a is equal to 9 over 2. Let's work out b, because I need to know what both fractions are. So you go back and you say, look, just like I chose a number for x, which helped me, what other number can I choose for x that will help me work out what b is? So you don't want to choose 3 this time. That we've already done. That helped. It got me what a was. What about taking a look at this bracket? What can I put for x that'll make this become very, very easy to deal with? In fact, it'll make it disappear. So something plus 1. What about minus 1? If I put minus 1 here, then that'll work. That'll make it disappear, because minus 1 plus 1 is 0. So I'm going to be left with 0 here. Minus 1 take away 3 is minus 4. So I'll have minus 4b. And still sticking with x is minus 1. 6 times minus 1 is minus 6. So my equation is minus 6 is equal to minus 4b. I can cancel the minuses. I can divide by 4. And now you have your b. Your b is equal to 6 over 4, which simplifies to 3 over 2. Now remember, the purpose was not to find out what a and b are. The purpose was to get the fraction split into 2. So you can't just stop there. You can't say, okay, I found out what a and b are, and forget what the question actually was. The question was, here's your fraction. It was 6x over x minus 3, x plus 1. And the question was, can we split that into 2 fractions? So originally the best we could do was to say, we know the first fraction is going to have x minus 3 on the bottom, but a number we're just going to call a on the top. So that's what we wrote to begin with. The second fraction, we knew what the bottom was because we can see it just right there. It's going to have x plus 1 at the bottom. We didn't know what the top was, so we just wrote b. But now, because of the work we've just done, we know what a is and we know what b is. So we can write the full answer. A is 9 over 2, so that can come here. Now watch the way I write 9 over 2. I'm going to write the 9 on the top, and the 2 can just join whatever it is at the bottom already. And similarly with the b, we've got b is 3 over 2, so I'm going to write the 3 over 2, 3 on the top, 2 on the bottom, and that's my b, so I can take the b away. And that's it, that's done. You've done your first real A-level question, A-level year 2 maths question, which is called splitting fractions, partial fractions, and you've managed to split this into 2 fractions. You can test it, you can check it by multiplying these fractions out, adding these fractions, and see that it does get you to 6x over x minus 3x plus 1, but I'll let you do that on your own. Let's see how much of that you actually saw and can repeat. So let's just go through that. From here, so we've worked out what a is. We substituted in x is 3. Now we're substituting x is minus 1, so that gives us an equation for b, which we solved to get b is 3 over 2. Can you remember what we did next? Good, we wrote out the fraction that we're asked to split, and we write it initially with the a and the b. We know what the denominators are going to be because we can see the 2 brackets, so 1 bracket on each fraction. And then we just bring in our 2 answers for a and b. So a is 9 over 2, can be written with the 9 on the top, 2 on the bottom. B is 3 over 2, can be written with 3 on the top, b on the bottom. So that's just the last bit. It's worth just going over that again. Good. Okay, see you tomorrow for the next lesson, more partial fractions. And if this was a little bit tough for you, then do make sure you just watch it again, go over it one more time, and second time is always easier, inshallah, if God wills. Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be with you, and the blessings and mercy of God.